In this video, I wanted to go over all the equations of a line. So just a regular linear equation. There are three equations for a line. The first one being slope-intercept. So the slope-intercept I always call home, and that is mx plus b. This is the one we most recognize. And I call it home because no matter what part or what equation I'm given, I usually come back to home, meaning I always try to get it in this format, mx plus b, because I know some things. So m is called the slope, and b is called the intercept. And that is why it is literally called the slope-intercept form. So b is the y-intercept and m is the slope. So if we were given, let's just say 2x plus 4, this is the format that we usually start from to graph. So I know my y-intercept, intercept is the y, so I go up the y and that will be at 4, 1, 2, 3, 4. So I'm crossing the y-axis. This is my x, this is my y. I'm crossing the y-axis at 4. We could also think about this as when x is 0, meaning if I plug in 0 for x, that would make y 4, because 2 times 0, that goes to 0, then y would equal 4. So when x is 0, y is 4. That is the point 0, 4. So for this particular example, our intercept is 4. So that's where we usually start when we're graphing something, and then we go right to the slope. So I go to my m term, which in this case m is 2, or we could say 2 over 1. And if you remember, slope is rise over run, or change in y over change in x. All that means is I'm going up first, up or down, and then right or left. So if everybody's positive, I'm going to go up 2, 1, 2, and over 1. So I could keep going up 2 over 1, up 2 over 1, and then I could just draw my line. So the other thing, if you needed to graph more, you could certainly just plug in some points and then connect the dots. So if I've been given an equation, then I can just plug in anything for x and get the resulting y, meaning the coordinating y. So same thing here, this would be when x is 1. If I plug in 1 for x, that would be 2 times 1 is 2 plus 4, that would be 6. And that makes sense because I went up 2 here. So that's when y is 6 and I went over 1. So this point here is 1, 6. When x is 1, y is 6. So that is the slope-intercept form, mx plus b. So let's go over another format. Often we are given the point-slope form. So that is literally, sometimes it looks a little bit funny, but that is when we are given a point and a slope. So this will be given, this is the format. So oftentimes if you're given a story problem and they will give you a slope and a point. So let's say, again, we have a slope of 2, and let's say we are given the point 1, 5, let's say. So in this case, we do not have the intercept, so we don't know where to start directly. But we could go ahead and plug this into our formula here. So if I were given a point and a slope, I would literally keep the y and I would subtract the y term. So in this case, that would be 5. So y minus 5 equals our slope times x minus my x term, which is 1. So sometimes that's a little bit confusing. We won't go right into graphing it just yet. But if I'm given a point and a slope, we could use point-slope form. So this is point-slope form. Now, if I needed to, I could leave it like that, or if I needed to get it into mx plus b, that would be the easiest way to graph it. Or honestly, we could just start with this point, right? I could start at 1, 5, 1, 2, 3, 4, 5. That would be my first point, and then I just go up 2 over 1 from there. Up 2 over 1. So that would be, if this is 5, that would be 7 and over 1, so that would be 2 comma 7. So I could just double check again in this format. If I plugged in 2 for x, that would be 2 minus 1 equals y minus 5. And if I solve this, 2 minus 1 is 1. 1 times 2 is 2. Y minus 5 equals 2. And I add 5 to both sides. That would give me 7. So that makes sense. When x is 2, y is 7. So I could just keep it in that format if that is what is asked of me, or if that's easier. Otherwise, I could also change this or rearrange it into mx plus b or slope-intercept. Oftentimes we're asked to give a different format other than what we are given. So if I were given point slope, or I were given a point and a slope and asked to change it to y or slope-intercept form, I could certainly do that. So again, if I needed to put this in y equals mx plus b, I'm just going to solve for y. So in order to do that, I'm going to make this side look a little bit easier. I will distribute that 2. So I would have y minus 5 left on the left, and that would be 2x minus 2 if I distribute that 2. Then I would just add the 5 to both sides. And I can't add the 5 to the x term, but I can combine like terms, so I add it to the negative 2. So in this case, that would be y equals 2x negative 2 plus 5, or 5 minus 2. That would be a positive 3. So now that looks like mx plus b. So this is my slope, which we already had, and now this is my y-intercept, which makes sense because if I keep extending this line, if I went down 2 and over 1, that would make sense that my y-intercept should be at 3, or 0 comma 3. When x is 0, y should be 3. So that would be changing from point slope form to slope-intercept. So let's take it a step further, or let's do another example of standard form. So standard form is the final form that we don't often use, but it will sometimes come up. Sometimes we are given the standard and then we are asked to put it in the other formats, point slope or slope-intercept. So let's say we were given 2x plus 3x equals 6. Now if I were asked, oops, I'm sorry, this is supposed to be y. Be y. That makes a lot more sense, right? So if I am asked to solve or change to slope-intercept, all I'm going to do is solve for y. So in order to do that, I'm going to keep this term and subtract the 2x from both sides. These two can't combine, so I will just keep them separate. I'm going to put my x term first because I like to see mx plus b. So then I still have my 3y. So in order to get y by itself, I'm going to divide both sides by 3. So this one might start to look a little bit funny, but that's okay. We often have fractions when we're dealing with slope-intercept form. So in that case, our slope would be negative 2 over 3. So remember, if I divide, I have to divide the whole side because this is an equation that I have to make sure I do the same thing on both sides. So I have to divide both of these terms by 3. So it's negative 2/3 x. That makes us think, okay, that's the whole coefficient or the whole m. So m is negative 2/3. And then 6 divided by 3, that would be a positive 2. So again, if I needed to graph this, so if I were given a standard form, I could still graph it, and the easiest way to graph is to put it in slope-intercept or mx plus b. So again, I can go to my intercept at 2, and in this case, I have a negative slope. So I'm going to go down 2 and to the right 3. 1, 2, 3. So remember, if you have a negative slope, only one of them, one direction will be negative. Meaning normally, if I have a positive slope, I'm going to go up and to the right, up to the right, up to the right. This way is a positive slope. If I have a negative slope, I'm going to either go down and then still to the right. Down is the negative, that makes it negative, but the right would still be positive. Because if I go down and left, now they're both negative. So that would be a negative over negative, which is just a positive. So that might be a little bit more information than you need, but just to be sure, I can either go down and to the right, or I could go up and to the left. So either or, down is negative, but then I still have to go positive, or to the left would be a negative. So if I go up, that's my positive, and then to the left. So if you remember, we can either write this as negative 2 over 3 or 2 over negative 3. Either way, that's the same. We can also put it in the front. That would still be negative. One of them has to be negative, but they both can't be negative. So that's just a quick review on how to draw the slope. If I have a negative slope, it has to go up to the left. So that would be how to graph if you were given the standard form. And now oftentimes we would have to go the other way. So the only tricky thing about standard form is, let's say we were given mx plus b, or slope-intercept. Let's say we have 3x plus 7. And we were asked to put this in standard form. So the only thing is I have to have all my x's and y's on the same side. So if you remember, ax plus by, and now big A and big B are just coefficients, that's all. And big C is just a constant. So all that is, for this case, I would just move the x over to the other side. So that would be a negative 3x plus just a regular y, and that would equal 7. So easy enough, that would be our standard form. Now, let's say we had a fraction. So in that past example, let's say we had a negative 2/3 for our slope. But we had this plus 7, so that's a different line, a different intercept. So in this case, I would still want to move the x term over. So in that case, I would add 2/3 to both sides. So that would be a positive 2/3 x, and I would still have my just one y, and that equals 7. So the only difference now with standard form is I don't want any fractions. That's the only detail you have to remember. No fractions. So I wouldn't want to leave it like this. To get rid of that fraction, I could multiply the entire equation, both sides, by 3. That way I would get rid of this fraction. But remember, we have to distribute and make sure he gets to everybody. So that would give me a final answer of, that would be 2x, because my 3's cancel out. Then when I multiply the y, that would be a plus 3y. And then I have to multiply the final side, the right side as well. So that would be 3 times 7 would be 21. So this would really be the standard form of this original equation. So this would be slope-intercept, and this would be standard. So those are the equations of a line. Feel free to comment below if you have any questions.